Assalamu alaikum wa rahmatullah. This is the 216L Engineering Drawing and Workshop course, lecture number 2. In this lecture, we will revise the orthographic projection and we will do some exercises, and we will talk about first angle method and second and third and fourth angle projections, and we'll focus on the first and third angle projections, and then we will see how we can use the miter line to draw the multiviews, and we'll talk about line convention in general. We'll focus on type of edges, types of lines, surfaces, and the tangent surfaces, and the presence of lines. Guys, just to remind you, multi-view drawing we talked about in the previous lecture, it is the orthographic projection method, which is a parallel projection method. So multi-view drawing is a set of related images that are created by viewing the object from different directions. We'll talk about the direction from the front view, from the side view. We have both right and left, top and bottom and back. This is just an example. If we have this 3D object, as you see, this is the width of the object. And this is the depth of the object. And this is the height of the object. So width and height can be seen from the front view. Depth and height can be seen from the side view. Width and depth can be seen from the top view. In this case, if we are facing the front view exactly, you will see this is as a front view, as I told you, with height. And this is the side view, where we have the depth and the height also. And this is the top side view, the top view, sorry, where is the this height, this length is the depth, and this length is the width. Now, the method, if you want to imagine the multi-views, in order to write or draw the multi-views on a paper, you can imagine the solution using two ways. The first way, revolve the object, as you see here, revolve the object. Okay, imagine that it is in your hand, and then revolve it to see the front view, and revolve it back to see the side view or right side view, as in this example. Rotate it also back to front, and then rotate to check the top view like this. The second method, imagine that you are trying to rotate around the object to look perpendicular to the front view like this. As you see here, we have this face and this face in the front view, and then rotate to face the right side view, where your eye view parallel to the projection view. I'll see this is the surface we can see from side view, and then rotate to the imagine that you are looking at the top view like this. Imagine what you will see, or what projection type you have here. So here, guys, we have this surface here and this surface here, where is the top view. Now you can imagine also, as I told you, that your part inside the glass box, and you will project all of the edges on that glass box, and you will, in this case, you will get the multi-views. You will get the front view here on the front side, you will get the right side view on the right side, you will get the top view on the top side, the left view on the left side, the back view on the back side, and so on the bottom, and then try to unfold. Just to understand how you can draw the multi-views, it's very important. Try to unfold this box like this. Why? And remember that when you draw the multi-views, you should remember the unfold. Why? Listen to me, because in the front view, this edge and this edge is common, are common between, or this edge is common with the top view. This edge and this edge common between the bottom view and the front view. And this edge and this edge common in the side view, and this edge and this edge common between the front and side view, and so on. And second thing, you have to remember that the front view always at the middle. So the top of the top view, the top of the front view will be the top. At the bottom of the front view will be the bottom view. To the right side, to the right of the front view, we have the right side view. To the left of front view, we have the left side view. And the rear view can be here or there or there. It's up to you. And then you can look at the multi-views like this. So as you see, front view, right, left, top, bottom, and rear view. Next, now as you see, forget the glass box surfaces. Just put the multi-views, we'll get like this. These are the multi-views. And as you see here, in the from the front view, we have extension lines to the side view, left side view. We have extension lines from each edge to the right side view. We have extension lines from the front toward the top view. We have extension lines from the front toward the bottom view, and so on. And this is, as I told you, height is common between the side and rear and front, while the width is common between the top and the front, while the depth common between front and side view, and all of the side views, As a summary, if you have a problem and this part is given, imagine that this part on a glass box, try to get multi-views, unfold the glass box, and then you will get the result like this. Now, alignment of views, it's very important to understand that the alignment should be correct always. How? If we use a first angle, different than third angle projection. In general, guys, if this is the front view, by the way, if you have three views like this, the middle one should be, the one at the middle here, should be the front view. So why this is a middle view? Because we have something at the top of that view, and we have a view to the right of that view. So this should be the front view. In this case, this should be the right. This should be the top view. Now, as you see in this example, which is wrong and not recommended. Now, this is the front view, should be aligned with the top view, and the side view aligned with to the front view. So the top view should be moved a little to the left, and the right should be moved a little to the down, so that this edge should align with this edge, and this edge should align with this edge. And this is same thing. This is the front view, this is the bottom view, this is the right side view. The right should be to the right of the front, and the bottom should be below the front view, aligned with the front view. And by the way, guys, this type of projection called first angle, it is correct if it's a first angle. I will talk about this one now. Now, guys, what is the third angle projection? To understand the systems we have four options to make the projection: first angle, second angle, third angle, fourth angle. In the third angle, guys, we will imagine that the object here in this behind this surface and under this surface, and if you want to get the front view, you will look from here to get the front view. So in this case, the projection plane between the observer and the object. In this case, the front will be in its original location. Now, if you want to get the right side view, again, you will imagine that the observer here, and there is, as you see here in this example, the observer here, and there is a projection plane between the observer and the object. In this case, you will get the right side view on the right. Same thing on the left side view, guys. Imagine that the observer here look perpendicular to the left side view, and there is a projection plane in between, so you will get the left and the left. The top, same thing, the top on the top and the bottom on the bottom. This is the original orientation of multi-views in third angle projection. And mainly we are, if you have a drawing, multi-view drawing, and the author or the writer want to show you that this is third angle, you will see mainly this symbol. As you see in this symbol, imagine that this is a 3D object. If you look from left, you will see this circle. So this circle is visible. As you see, the inner circle visible, and the larger circle here, it's also visible. So if this is visible and this visible, that means you are looking to the left side view, and the left side view in the left. So this is a third angle projection method. Again, imagine that this is a 3D object, and here we have a circle. If you look from left, we will see this as a circle, and this circle is not hidden, it is visible. And also we have a larger circle here, will be from left visible also. So we have a larger circle visible. If both circles are visible, that means you are looking to the left. So this is the left side view in the left side of the front view. That means the original orientation, which is the third angle projection method. If this circle is dashed or hidden line, that means you are looking to the right side view. In this case, this will be a right side view drawn on the left side view. That means it is a first angle. I will talk about the first angle now. Now, what is the first angle projection? In general, the biggest difference between third angle projection and the first angle projection is how the planes of the glass box are unfolded. As you see, in other words, where is the location of the projection plane? In this method, the first angle method, imagine that we have the object here, and the observer here. If you want to get the front view, the observer will come here. So there is no any projection plane between the observer and the object, but the projection plane behind the object. So as you see here, the observer in this side for the front view, looking to the front view, but the projection, it is behind the object. So we are projecting on the other side. For the front, it doesn't matter because the front will be the first projection. Now, if you want to get the right, imagine that the observer here on this from here looking direct perpendicular to this surface and this surface, try to get the right side view, and there is no projection plane in between. In the first angle method, the projection plane will be behind the object, and you are projecting toward that plane. In this case, you will get the right, not on the right, on the left. So the right side view will be in the left. Same thing for the left will be on the right. The top view, same thing, guys. The top view, imagine that the observer here looking direct or perpendicular to this surface and this surface and this surface. Try to get the top view, and the work plane behind the object, which is at the bottom of the front view. At the bottom, sorry. So we are projecting toward this work plane. So as you see, the top view will be, the location of the top view will be at the bottom, like the location of the right will be at the left. In this case, this is the first angle method. So actually, what is the difference between first angle and third angle? The third angle, it is the original orientation or positioning of the multi-views, while in the first angle, the top view will be on the bottom, at the bottom. The bottom view will be at the top of the front view. The right will be in the left side. The left will be in the right side, and I will show you an example. As you see in this example, projection simple, like you see here, we have this circle, it is a visible. This circle, it's a visible. That means if we are looking from right side view, yes, I can see the larger circle as a visible, but the smaller circle here will be hidden because I'm looking from the right view. That means what? That means this is not the right, this is the left view. But we know that the left should be in the left. Why the left in the right? That means this is first angle method. And here, this is the third angle method. As you see, that the view, as a view, it is same. If you are using the first angle or third angle, the view as a view, it is same exactly, no difference. But the location of the view swapped. Now, look, we have here the front view. This is the front view. Now, in third angle projection method, if this is the front view, this should be top view, and this is the right view, and this is the left view, and this is the bottom view. Now, how can I make a first angle projection from the third one? Now, this is the front view as it is. Now, take the left side view to the right, as you see here, the left on the right. Then take the right to the left, as you see here, the right on the left. Now, take the top view, place it at the bottom, as you see here, and take the bottom, place it at the top, as you see here. So, as you see, this in the third angle method, this is the bottom view. It's exactly same here, but location different. And the top view, same exactly, but location different. The right, it is the right, same exactly, but moved to the left. The left, same exactly here as here, but moved to the right. That's it. So we can draw the third angle projection or second angle projection. Why we are giving third and first? Because most engineers around the world are using both methods, the first angle and the third angle. So we have to learn. Now guys, let us talk about the edge. Edge, it is a line that represents the boundary between two faces. As you see here, this is an edge, this is an edge, this is an edge, this is an edge, original edge. Sometimes, as you see here, sometimes the edge, it's not clear like this, not original. Maybe it is the limit of a surface. So we have surface limit, which is a line that represents the last visible part of the curved surface, as you see here. If you try to put your finger on the surface, you will reach this limit. As you see, this limit will be represented as a line. If it's visible, it will be visible line. If it's hidden, it will be hidden line in projection views. As you see in the sphere here, again, we have surface limit around the sphere. So for cylinder, we have surface limit from top, surface limit from bottom, as you see, and sometimes from side to side. We have surface also. I see this is a surface, this is a surface, this is a surface, this is a planar surface, this is curved surface, and so on. Now this is just an activity, guys. Let us check we understood the concept or not. We should identify the component here. For each component given a name, we have to identify this component. It is an edge or surface limit or surface. As example, number one, this edge, guys. This is just an edge because, as you see, this edge, it is intersection between this surface and this surface. So if you put your finger here, you will feel that really there is an edge here or angle. So it is just an edge. Number two, guys, here we have also a circular edge. This is linear edge, but this is a circular edge. If you put your finger there and try to feel what's there, you will feel that there's a sharp edge there. This is an edge also. Number three, this one, it is, as you see, if you go on that surface, cylindrical surface, you will reach the last point here. That means here we have the surface limit. If you put your finger there and try to feel what's there, you will not feel that there is an edge. It's a smooth surface, but here, as you see, from this angle of view, you will feel that there is a line here or an edge. This is called a surface limit, not a real edge. But this surface limit should be represented as a solid line in the projection views if it is visible, or hidden line in the projection views if it is hidden, not visible. Number four, again, this is also circular edge. And number five here, it is just a surface. curved surface. Sorry, it should be curved surface. I forgot. Should be surface here. So let me reset all. Again, this is edge and this is edge also, while the number 3 it is a surface limit, number 4 it is just a surface. Number 4 again, reset. This is number 1 edge, this is edge, and number 3 it is a surface limit, number 4 it is an edge, number 5 it is a surface, number 6 here this is planar surface, so you have surface. Number 7 this surface inside it is a curved surface, cylindrical surface. Number 8, which is this one, this is just a planar surface also. So we have 4 surfaces, 3 edges and 1 surface limit. Now, just to let us revise again the idea of projection using a glass box concept. If you have this object and you want to see how we project the line or the edge AB, say that this is the front view, all of this line will become just a point. But the same line from the side view, this point will be projected here, and this point will be projected here. We will get a same length line, this length, this line, and this line, same length. On the top view, same thing. This point will be projected here, and this point will be projected here. We will get the same length line. So the line AB, same line AB here, and it look like this in the multi-view drawing. So this is the point A, or the line AP, it's just one point on the front view. The line AP, just one line, same length in the right side view. The line AP, same length line on the top view. What about this surface? Same idea. For this surface, guys, I'll see we are projecting all of these lines to here. You will get 2 lines, same length of this line plus this line. Now, on the side, right side view, we'll get this line will be here, same length. This line will be here, same length. This point will project here. We'll get this line, same this length, and same this line, and this line from here to here, same, and then go up or down, same length. As you see, all of this surface from the side view is just one line. In the top view, all of this surface will become just 2 lines. The first line, second line. While this line, it's hidden under visible, we can't see it. This line is just 1 point. This line is just 1 point. This line is just 1 point. This line from here to here, but hidden under the visible line. And on the multi-views, you'll see it like this. What about, let's say that this example, this surface again will become one line, this become like this on the top view. This is just repetition, I think. Now, we have here slanted edge or inclined edge or line like this AB, and you want to see how we can project it. Now, guys, this is the plane, this is the front view. This point here, we will get smaller line, shorter line, because we will take this line length, cosine this angle, we will get this line. So this point projected here, and this point here, you will get this line. But as you see, in the side view, this point here, will get the same length line. On the top view, this point here and this point here will get shorter line. So this length is less than this length. By the way, we have to measure the length and the angle. No, just take this point here and this point, project it here, and then connect the line. You will get the line. Now, what about this surface? Same idea. On the top view, all of these corners will be projected here. We'll get a rectangle with area less than this rectangle because we are projecting here. On the side view, this point here, all of this surface will become just one line. on the top view, as you see here, this edge will become here, this edge will become here, this edge here, this edge here. Again, we will get rectangle smaller than the rectangle because we are projecting the top view. Again, all of this surface is just one line on the side view because this surface perpendicular to this view, this surface parallel, not parallel, but slanted with an angle with this top view, so we'll get smaller rectangle, and same thing for the front view, we'll get smaller rectangle. What about this oblique line? This line oblique, that means not parallel to x-axis, not parallel to y-axis, not parallel to z-axis, not parallel to xy plane, not parallel to xz plane, not parallel to yz plane. How we can project it? It's very easy. Just take this point, project here, take this point, project it here perpendicularly, and then connect. No matter what's the length, no matter what's the angle of the original line, just connect the points. Same thing from the side view. Project this point here and this point here, connect. Same thing with the top view, project here, project this point here, connect no matter what's the original edge length and angle. Now what about this oblique plane? Same idea. No matter what is the angle of this work plane, what are the length of this edge and this edge and this edge and that edge, just take this point, project it this point, project it this point, and this point, then connect them together. So as you see, this is the projection of this point, like this. This point become here, this point will become here, this point will become here, and this point become here. Connect them, you will get a rectangular shape, but not same this one. Same thing from the top view, this point here, this point here, this point here, this point here, and same thing from the side view. Just take the projection of each point and connect them, you will get the shape like this. No matter what is the angle of this oblique plane, what are the length of these edges. What about this shape also? As you see here, we have a cylindrical shape, and here we have edge, circular edge, this one. How we can project it? It's very easy also. Just take this point here and take the surface limit from here to here, project here. So we have a line, this line is visible, and we have another line under it which is hidden, but we can see it here. Now on the side view, A projected here and B to here, connected, you will get a line. Now this line length, guys, it is diameter length. On the top view, we'll get the same circle or semicircle, half circle. This A point will become here, this B point will become here, and draw a circle like this. So we'll get multi-views like this. Now, what about this surface? Cylindrical surface, same idea. This edge will become here, this edge will become here, this one hidden under this one. This surface limit is here, and this half circle, a quarter circle will become here, and we have hidden, can't see. From the side view, this all of this circle will become here. All this line, same length line, this circle, it's a one line, this line, it's a one line, this length and this length, it is actually diameter length. Diameter, the length equal to diameter of the circle. And from the top view, as you see, we have semicircle, same exactly this one, same dimensions. From the front view, we got a rectangle, this rectangle, and we have hidden rectangle, but hidden rectangle, it is exactly under the visible one, we can see it. Now we talked about views of surfaces. Remember, we have normal surface, we could have normal surfaces, we could have slanted surface or oblique surface. And we learned how we can consider the projection of these planes. And again, if an angle is a normal plane, in a normal plane, a plane parallel to the plane of projection, it will be show true size. Otherwise, not same size. Example, this is 45 on the front view. It's on a plane parallel to the front view, parallel to the observer eyes view. So it will be same angle. But my advice, forget the angle. Just draw the points and connect them. This is not a parallel this angle not on plane parallel to the observer eye plane, or say that projection plane. It is slanted. So this 45 angle, it will not be 45 angle on the projection. So this is not 45 angle. Again, as advice, forget what's the angle. Just project these points. Sorry, just to project the points, this point and this point and this point. Then draw it as you see here. This point is this one is this one, and this one is this one. Connect them, you'll get this one. Now I will show you this example on Inventor. As you see, we have a flat surface. This flat surface viewed from several different positions. You will get the same surface from the side view, same surface from the top view, but with different dimensions, different length, because this line length will be, as you see, from side view like this, while it in the top view like this. It depends on the say that the original dimensions. So let me show you the Inventor example. This is the example. I see this is the standard surface. Now I will show you from the front view. See, all of this surface will become just two lines, same angle. So we can say that one line. Let me go to the right side view. As you see, this is the slanted surface. See, same surface shape but different dimensions. I will go back to the front view. I will show you the top view. Same shape but different angle, different dimensions. I will go back to the front view. Then I will show you from the left side view. It will be hidden in the left side view. Let me go back to the isometric like this. If you want, we can use it. Imagine that we are holding the object on our hand and try to look to the object like this. Rotate to see all of the sides. Okay. Now, projection of an object having curved surface, how we can get the projection. In this case, guys, we have to talk about two things: the intersection between surfaces and the surfaces where they are tangent to each other. So as you see in example, this example, here we have a flat surface, here we have a curved surface. The curved surface connected to the flat surface, not tangent. There is an edge in between. If you put your finger there, you'll feel that there is a sharp edge. So we have an edge here. And same thing, this flat surface, curved surface, it is intersection, not tangent. While here in this example, the top surface and this curved surface, they are tangent to each other. If you put your finger there, you will feel that there is a smooth surface. You will not find a sharp edge. So this is tangent surfaces. So actually between this surface and this surface, there is no an edge, or there is no an edge here. We should not draw a line here. And same thing here. In this example, we have two types. Here we have tangent surfaces and here we have intersection. This flat surface, planar surface, connected to this curved surface at the tangent point. So they are tangent to each other. There will be no an edge in between. While this curved surface and this planar surface connected in a point where they are intersect each other. So we have intersection here. So it should be a line or edge in between. In this example, guys, as you see, we have isometric view, front view, top view, right side view. Now we want to check. Let me ask you a question. As you see here, we have a flat surface, curved surface, flat surface, and they are tangent to each other. Should we draw a line here at the tangent point here? I see this is the tangent point here. No, because this surface and this surface, they are flat. There is no edge in between. If you put your finger there, you will feel it is just one surface. One surface, there is no edge here. And regarding the right side view, same idea. If you look from the side view, we have this planar surface and this circular surface or curved surface, and they are not intersecting. They are tangent to each other. So there is no edge here in between. Put your finger there, you will feel try to feel the surface, you'll feel that there is just one surface only, not two surfaces. There is no an edge or sharp edge or corner here. Now in this example, we have, as you see, flat surface, curved surface, and other curved surface. All of these surfaces are tangent. Look to here, see, we have flat surface, and we have a curved surface, and see the curved surface here also tangent to other curved surfaces. And this the intersection, not intersection, the connection between this curved surface and this curved surface, it is not say that at an angle here. So they are tangent to each other. There will be no line here. As you see here, there is no line. But here we have a line. This represents this corner, this corner. And the same thing from top view. We don't have a line here, no line here. And same thing, no line here and no line here, because all of these three surfaces are tangent to each other. If you put your hand there and try to feel the surface, it will be one surface, not more than one surface. You will not feel that there is an edge here or here. In this example, we have a planar surface and curved surface. As you see in the isometric, we have an edge here, original edge. Try to use your finger there. Try to feel the surface. You will feel that there is a sharp edge here, and so we have intersection here. It should be a line, visible line if it's visible, hidden if it's hidden. In our case, it is a visible line. And same thing from the side view. In the side view, we have a circular or curved surface and planar surface, and they are connected to each other at the intersection, not a tangent point. So there is an original edge here, as you see. So any edge on the isometric view should be represented on the multiviews. And in this example, guys, we have surface, 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 but here different than this example because they are tangent here before this surface and this surface. If you look to this curve, it is less than quarter of the circle. This curve less than quarter of the circle. So they will not intersect exactly at the quarter point. But in this case, see, we have a curved surface and other curved surface. They are connecting tangentially, yes, I know, but they connecting exactly at the quarter point. So they are making like a flat surface here, a flat surface here. So it should be a line there, even it is a tangent. It should be a line here to represent the surface limit of this. Why quarter? Because if the curve reach the quarter point, that means it reached the surface limit. So we have surface limit if you go from up to down, and surface limit if you go from down to up to the top like this. So we have a line here. And as you see on the but from side view, if you look to the right side view, there is no surface limit here. And you will feel that this surface and this surface, they are one surface, tangent surfaces, and no surface limit. There will be no line in between. Why here again we have a line? Because this curve and this curve, they are tangent, and they are tangent at the quarter point. That means we have at the quarter point we have exactly a surface limit, should be represented as an edge here. And you will feel that this curve and this curve actually are making like a flat edge here, a flat surface here. So this is called the surface limit. This is example again. As you see here, we have a sharp edge here. So we have two edges, and you see on the isometric exactly they are there. We should represent them here also. And this example, as you see here, we have a sharp edge. We have intersection. Here we have intersection. And this example, we have a surface, tangent surfaces. So here we have tangent surface. We don't have, as you see on this point, a surface limit. From the top view, there is no, sorry, let me go back. There is no edge here. And same thing from the side view, there is no edge here because they are tangents. And the last example, here we don't have a line here, we don't have a line here or line here, because they are tangent to each other. And here, if you have two curves like this, they are tangent, not a quarter point, so you will not get a surface limit. So there is no any line here. From side view, we have just this line, because not because of this curve, because we have a sharp edge here, or corner, or intersection point. In this example, as you see here, we have a line, and here we have a line. This line because of this edge, and this line because we have a surface, flat surface, as you see here. Or we can say that a surface limit of this curve, or a surface limit of this curve. So we have an edge here. This edge, again, it's just a surface limit, or the tangent surface between this arc and this arc should be presented on the top view as a line. In this example, again, we have a line here, we have a curved surface, they are connecting at the quarter point, so we have a surface limit, and here we have a line because we have this edge. In this example also, guys, it's very important to talk about it. This is the projection. It's very important what we are seeing here, guys. This is the emitter line. These are the extension lines from the front to the side, and these are the extension lines from front to top, and extension lines back from top to the side view to draw the side view. Now this red line, what it is this red line? Actually, this red line, guys, represent the intersection between this surface and this surface. So we have an edge in between here, How we can know where is the edge location? As you see, we extend this line on the top view until intersect with the circle, then get it back to toward the front view, and then connect it like this. What about this example? As you see, front view, top view, no line exists here. Why? I will show you. And here we have the emitter line. We are extending the front toward the side and the top toward the side to draw the side view. And here there is a gap. There is no line to connect this edge with this edge. Why? Because this surface, as you see, intersect with this surface exactly at the tangent point. So they are tangent to each other. Actually, if you try to feel this surface, if you try to touch this surface, you will not feel that there is an edge here or sharp edge, because this surface and this surface, they are tangent to each other. So there will be no line here. What about this example? Again, top view, this is the front view, and this is the side view. Emitter line, connect or extend the front view toward the side, extend the top toward the side, you'll get the side. Now, here also, we don't have a line. We don't have a line because same, this surface and this surface, they are tangent. Try to touch this surface, you will not feel that there is an edge here because they are tangent to each other. But the problem, how we can know exactly this edge length from here to here, where is the end of this line? We have to draw the top first. So from the top, draw this line, take the tangent point back to the front view. You will know where is the end of this line and this line. What about this one? Same, but here we have two, say that we have two cases. Again, extend to the side view. Now here we don't have a line because from here to here we have a surface, and here we have a surface. They are tangent to each other. There will be no line in between. But where is the end of this point? Where is this point? I don't know exactly. So we have to take it from the top view. On the top view, this edge will be tangent like this at the quarter point exactly. And this front edge will be tangent like this. So we'll extend this line until intersect the circle, then get it back to the front view. You will get this line. But what are these two hidden lines? Actually, this is a visible line from here to here. But we have a hidden edge from back. The hidden edge from back, as you see, it will not stop here. It will continue until reach this quarter point or quadrant point. So from here to here, it's a hidden edge, and here, hidden line. This hidden line represents this hidden edge. And this hidden line represents the same, but from the bottom. Now let us talk about the line convention. Line convention. Now regarding the line convention, as you see, we should talk about the precedence of coincide lines, how we can draw hidden lines, or how we can draw the center lines. Now, in this example, we talked about it in the previous class. If you draw the multiviews, you will get these multiviews. Now, as you see here, we have surface limit of a hidden hole, and at the same time here we have corner. So the visible line will be hide the hidden line, the precedence or the priority for the visible line. And same thing here, as you see, we have hidden line. This corner is hidden, and we have center line. So we'll keep the hidden line because the priority for the hidden line over the center line. And here we have a surface limit should be kept like this. On the top view, I'll see this is a corner or edge. At the same time, we have center, so we extend a center line as you see outside the view with thin line and space here, just to tell you that there is an edge here. At the same time, there is an axis. As you see here, we have surface limit for hidden cylinder, and here we have surface limit for hidden cylinder. At the same time, we have this edge, it's hidden also. So hidden over hidden doesn't matter, both of them hidden. This is just an activity, guys. In this activity, we want to check that we understand the concept. We want to check what is number 1, what is number 2, what's number 3, number 4. Is it say that visible line, is it hidden line or center line? It should be there. Now guys, number 1 here, what should be here? Actually, this is the front view, this is top view. From where we get the line here, it's a center or axis of this hole. So it will be a center line, and nothing will prevent prevent us to show the center line. So it is center line. Number 2 here, what is here? Same thing, it's a center line, but unfortunately we have a hidden line here, hidden edge here at the same location. So it should be hidden line, not center line, because the priority for the hidden line. Number 3 here, what we have here? Yes, we have this corner, this edge, it's a visible, and at the same time we have center, so we should keep the visible, not the center. We can extend the center outside, so it should be visible. And by the way, we have also hidden line here, so we have a visible corner and we have hidden corner from back, but the priority for the visible line. And last line, number 4, from where we get this line, from this corner visible, and this corner hidden, visible over hidden, it will be visible like this. Now let's talk about hidden line drawing. Hidden line should join a visible line always. We have an exception, it extends from a visible line. Example. Now guys, in this example, I see we have isometric view, and this is the top, this is the front view. As you see, this surface is this surface. We have this visible edge, here, and this is visible edge, and this visible edge. What is this hidden line? This hidden line actually represents the back edge here, and this edge, this point will be projected to here, that point, and the other point projected to here, that point. And if we connect it from here to here, there is no any visible line that can hide this hidden line. So we should keep the hidden line to represent the hidden edge. But remember that the hidden line in general should join a visible line. So this hidden line from here should join the visible line, no gap. I can't, there is no misunderstand, because I can distinguish that this line and this line, they are totally different edges. But this hidden line and this visible line, are they one edge or two different edges? If this hidden line and this visible line represent one edge, a gap should be, there should be no gap in between to show that this is just one edge. But in our case, this visible line, it is the front edge. or the edge on the front, while this hidden line, it's a hidden edge on the back. So they are totally different edges, and they are at the same location. So we have to keep a gap in between to show that this edge and this edge, they are not same. Why no gap here? Because I know if I connect it from here, I know that this edge is not this edge because they are perpendicular to each other, not same location. What about this example? Again, this surface is this surface. Okay, so we have this slanted edge, this is slanted edge. What about this hidden line? This hidden line represents the hidden edge here, slanted hidden edge here. This point projected to here, this point, and that point to here, this point. And as you see, this hidden edge is not hidden or didn't become under a visible line. So we have to keep the hidden line here. Now ask yourself, now regarding this line and this line, we know exactly that this edge and this edge, they are totally different. But this edge and this edge, little confusing. Are they same edge or different edges? Let us check. This hidden line from here, this edge from here. So totally different. And there is, by the way, see, there is a space in between. So here should be a space in between to distinguish between that they are a single edge or two different edges. Same thing here, guys. We have this surface. This is the front surface. From where we got this circular hidden line, actually this hidden edge or this hidden circle or this one or this one. Now, same idea. This hidden line, the concept or the rule says that the hidden line should join the visible line, except it extends from a visible line. Now, as you see here, this hidden line, and this visible line, they are not same. Hidden circle and visible circle, they are not same. This visible circle represents the front circle, and this hidden circle represents the back circle or this circle. So they are totally different at the same location. So we have to keep gap here and keep gap here. Now, guys, this is just an example to show you how we can make the projection for this part. I see this same idea here. Again, same idea here. So as you see, we have hidden line here, not extended from this visible. I'm sorry, because the movie, I have to stop the movie. I don't know how to stop it. Anyway, as you see here and here, we have to keep a gap because this line and this line, they are not same, and the same for the other one. Again, the second rule for hidden lines, intersection between hidden lines. So if you have two hidden lines intersect each other, they should be form L, T, V, or Y corner. In this example here, we have hidden line with hidden line, should make L, so connect it, don't keep gap. Here, like T, don't keep gap. Here, same thing, L. Here, same thing, L. Here, like Y or V. Here, same thing. Here, same thing. Here, same thing. So when a hidden line connects to hidden line, don't keep a gap in between. Now, the next rule, a curve hidden line should start on a center line. As you see here, we have a curve. Here we have curve. We should start at center line, from center line to center line, from center line to center line. So don't keep a gap here, don't keep gap here. Same thing here. Center line drawing, how you can draw center line. Center line should always start and end with long dash. So the small dash at the center, so then long, start, then end it by long. In circular view, short dash of center line should cross at the center of circle or arc, as I told you. The short dash should be here, crossing here at the center exactly. Center line should not extend between views. If you have multi-views like this one and like this one, don't extend the same center line from the front toward the top like this. Okay, keep a gap here. And same thing, keep a gap here and the short and the long dash should be at the end. For small holes, like guys, this hole it's large, so we have a space, enough space to show exactly the center line. Guys, in this case, we have a center line, and center line, it is, say that, at the same location of visible line, and we should not connect center line to visible line like this. Keep a space here, a space here. But here, it's crossing the visible line, no problem. Now, for the small circle, we don't have enough space to show the dashes here, long, small dash, long dash. So keep it like this, continuous line, but thin, not thick. Regarding here, guys, the axis of this hole, as you see, it is will be under the visible line. We should not connect it here and here to show the axis. Just extend it a little bit outside, thin line, not thick line, but keep a space here and space here. Now, regarding this hole, guys, as you see, here we have surface limit, here we have surface limit. We have to put the axis. The long dash should be extended outside a little bit. The long dash will be extended outside a little bit outside. Class activity, guys. Hidden line drawing. Okay. Now, for this edge, guys, should be connected like this or not. The rule says that the hidden line should join a visible line. Now, we have some say that we have a doubt about this edge and this edge. No, I know that exactly. This is a different edge than this one because the angle is 90 here. They are perpendicular to each other. So impossible to be there to be one edge. So we should not keep a gap. Connect. So here, correct or not? It is correct. Now, what about this one? Visible edge and visible edge should be connected like this without a gap. Yes, correct. What about this one? Hidden with visible, not one edge. Correct. Okay, what about this one? Oh, we have to think. We have a hidden edge and hidden edge. The rule says that hidden should join hidden. So this is wrong. We should not keep a gap here. And same thing here, guys. Hidden with hidden should form a T. So we should remove the gap. So this one is wrong. What about this one? We have a hidden line with visible line. Now I have a doubt. I don't know exactly. This line and this line, they are same, one edge or two different edges. If one edge, connect. Two different edges, keep a gap. Now this hidden line, we don't have line here. It is from the back edge. Okay, and this is the front. So we have front edge and back edge. So we have totally different edges, two different edges. So we have to keep a gap here. So this is correct. The last one, hidden line, join visible line, no doubt at all. So this will be correct and we should move. Now transferring the depth dimensions. As you see in the previous examples, we used the miter line. How we can use the miter line? Why we are using the miter line? Miter line to provide a fast, accurate method of constructing a third view. That means we have the front view, we have the top view. We will use the front and top view and the miter line to get the dimensions and the shape and size of the right side view. Or we have the front view, we have the right side view, construct the miter line to get the top view. So how we can do it? I will show you. Now, as you see, the miter line should be constructed on 45 angle exactly. Why? Because this length transferred to here. So we know that this length and this length, they are common between the top and the side view. So this should be a 45 angle. Now, if you constructed the front view like this, you can extend this edge to here, extend this edge to here, extend this hidden edge, extend this center line, extend here, and then select the distance between this view and this view, say one block or 1 centimeter, 2 centimeters, it's up to you. And then draw this line, draw the front view, the top view, sorry. So we have now the front and top view. Now, same distance here should be same distance here. So you can take this line to here, 2 centimeters, and then go like this, and then extend from front toward the side view, extend from front towards side view, extend the front towards side view, and then take this edge we talked before. You can take this edge to the right side of you, take this to the right side of you, take this one to the right side of you, take the center to the right side of you. You will get the shape of the right side of you if you just use the extension lines, as you see in this example. Now we have two multi-views like this, as you see. We took extension line from here to here, say that this distance is D, it should be same this distance. Okay, construct the metal line at 45 angle. Now you can take this edge to here, this surface limit to here, this center to here, this surface limit to here, this edge to here, this edge to here, and then extend this line here, extend this line here, extend this line here, and then construct the right side view. By the way, these extension lines should not be inside the view. So we have to remove all of these, and we should keep a gap here between these extension lines and the multi-view or the projection view, which is the top view here. And they should be thin, not thick. Thin, not thick. Same thing here, guys. So we can use, if you have the front and side view, you can use them to construct the top view, as you see here. Now in this example, guys, as you see, we have the front, we have the top. I will show you exactly what we should do. We will move from here to here a distance, say that extend this line to here, to this point, say that 2 centimeter, and this 2 centimeter should be between this view and this, the side view, and this view and this view. And then we will draw the miter line, extend this edge like this, extend like this, extend the top view from here like this, then take them to the side view and then try to draw the side view like this. So this is the miter line. These are extension lines, should be very thin. For this one, try to avoid keep the extension line inside the multi-view. But if you want to keep it like this to make it clear, it should be very thin. Now this is just a revision of multi-views. We are focusing more and more and more on projection views. We are using the multi-view method, which is the orthographic projection method. And we talked about first angle and third angle. Now let us check. If you have a part like this and you have, say that a projection plane in your hand like this, and you're trying to project this surface, again, this edge will become, this edge 4 inch exactly. This edge will become here 4 inch exactly. This line, it is not parallel to this surface, so we will project it with shorter line, using shorter line. So this edge will be shorter than this edge, and this edge should be here with shorter also. Connect them, you'll get this rectangle. Same thing for this surface and this surface. This surface will become here. This surface is this slanted surface will become here. This edge will become shorter because from here to here it is 2, while this line slanted line, it's larger than 2. But the projection of this point will become here. Projection of this point will become here. Connect them, you will get this line. So all of this surface is this surface. All of this surface is this surface. What about this? Same idea. This is planar surface, you will get the same in the top view. This is slanted surface, you will get smaller one. Here, same idea. This rectangle here, this rectangle but smaller. Same idea here, guys. Planar, exactly same. This is a smaller one here. Here, guys, this is slanted surface. This line is here. This line is here, and this line here. And this line is here, and this line is here. You will get smaller surface also. Same idea here, guys. This rectangular area or surface, same, exactly same area, same length, same height. This line will become here, guys. Here we have a surface limit will become here, and all of this circle will become line. All of this circle will become one line, so we'll get smaller surface than this one. This surface become here, this surface become here. You'll feel that they are on the same plane. For this one, we have a rectangle. This is the rectangle. same exactly of this rectangle. We have a hidden line here because we have a hidden edge here from the top view. We should represent it. For this one, guys, again, this surface is the rectangle, same dimension rectangle. Here we have hidden edge or this one, both of them here. This edge or this edge, hidden line here. What about this edge? This edge actually it is hidden line under visible, no need to represent it. While what about this example? We have this surface rectangle, this rectangle exact size. Here we have a hidden line, hidden edge, this corner hidden from here to here. And here also we have a hidden edge or this hidden edge from here to here. What about this one, this surface and this surface, and here we have curved surface. So we got smaller surface here. Why we have a line in between or edge in between? Actually, we have it on the isometric view. Try to touch this edge or this surface. You will feel that there are two different surfaces, and there is a sharp edge in between or edge in between. So we have to draw a line because we have intersection, not tangent here. For this one, guys, all of this surface will become one rectangle like this. All of this circle, it is just one line. This circle, one line shorter. This length, same length here, same length here, and this surface here. And these are examples, guys. If you have a cylindrical shape like this, we have circle. On the side view, say that visible circle, the outer circle, visible circle, the outer one, visible circle. Here we have hidden circle, but under this circle, from the front view, all of this surface, this one, all of this surface, this one, and the hidden hole, it is hidden line with axis. Same thing from the top view, and so on. Now let me show you this drawing example on Inventor. This is the same. Now look to the front view. We have hidden edge here, hidden hole here, hidden hole here, and hole here. Let me go to the top view, show the top view. I'll see here we have a visible hole. It is half of cylinder. So the cylinder, if you want to check the cylinder from the top view, you will see it as a rectangle. And if you face the circular shape of the hole, you will see a circle, and like this one, a circle. Go back to the front view. This is the right side view, guys. Here we have a hole here and hole here. This is hole visible, not hidden. And if you go to front again, left side view, you can't see the other features. All of the other features will be hidden. Now, guys, let me, this is drawing number 2. Let me show you the multi-views. I will go to File. You should not do that, but just to make it clear for you guys, I will open a drawing file. I'm waiting the inventor to open the drawing file. Now, let me bring the base. This is the base. Let me select the scale. Let me select larger scale, just to make it very clear for you. I will select scale, make it like this. Okay, I'll see. I will get back again for these hidden lines. I will project toward the top view like this, guys, and then take it to the right side of you. We'll get the projection to the right side of you, and this is the isometric view from this angle. By the way, guys, this in the modeling it's okay, but on the drawing sheet is not acceptable because we don't have an edge here, because this surface and this surface, they are tangent to each other. Now, guys, from where we got this hidden line and this hidden line, actually we have this hole and this hole. They are same size, same location. and this one surface, the bottom surface exactly here. So we got this one. The only thing missed here on the side view, guys, we have to place center or center lines for the circle, for this circle, for this circle, and also we have to place or draw axis between this line and this line, because we have already say that whole axis. Same thing between this one and this one, we have whole axis. It must be like this between this one and this one. It is whole axis to represent this one. Same thing here. Now it is completed. Sorry, I forgot this one also. Between this line and this line, we have an axis for this hole. Next, guys, we have this classwork and this classwork. Let me show you it in Inventor. I'm trying to make things easy for you to understand the object. So for this one, guys, this is the classwork number 1 for this lecture. As you see here, by the way, there should be no align here, but this is just modeling. It's acceptable, no problem. But if it's multi-view, we should remove this line, because actually there is no edge here, no line. This surface and this surface, they are totally different, but they are tangent at the same time. Now, guys, this is the front view, as you see here. This is the gap. You will feel that they are at the same level, but actually this one on the say that it is inside. This one and this one outside or on the front. This one same inside. Let me show you the top view. As you see here, top view, we have a hidden line. A hidden edge should be represented on top view. This line should be on the top view, guys. So if you draw multi-views, you have to draw it. There is no line here again. Side view, this is the side view, guys. Here we have a hidden, say that hidden cylinder or hidden hole. We should draw it as a rectangle, hidden rectangle with axis. Let me show you the multi-views of this one. Actually, if you are watching this video while doing the classwork, try to not get the solution and try to get the solution by yourself, not from the video. And if you struggled or stuck somewhere, you can refer back to the video and to see what's going on. My advice, guys, if you are doing the classwork now, please don't see the solution. Try to get it by yourself and then refer back to the video to check what's there. Now I will open a new file. It's a drawing file, and I want to place a projection. Okay, let me change the scale. And this is the top view, guys. And we will take the side view, right side view, like this. And just to remind you, this is the isometric view. Again, there should be no line here. We should remove it because this is a drawing sheet, not modeling apart. In modeling, acceptable to keep this line, but in drawing sheet like this, multi-views, we should not keep this line because this surface and this surface, they are tangent to each other. Now, what this hidden line from top view, we can't see this cylindrical hole, so we have to draw a rectangle. But we have hidden line here under visible, hidden line under visible. No need to draw it. But this hidden line should be, we should keep them. And also we have to add an axis to this hole, like this. Now, what this hidden line? It is this hidden edge from top view. Now, regarding the front view, we are not missing anything. We don't have from back any hidden lines. We have this edge, it's hidden, but it is under visible line. This edge under this edge. and this edge under this edge, so no need to draw it. This edge actually under this edge, no need to draw it. But the only thing missed here is the center line. We have to place a center line here, guys. And as you see, the center line extended outside a little bit. We can actually in Inventor control the scale of the segments. Never mind, not we are not trying to teach you Inventor, just show you the things to make things clear. Regarding the side view, guys, we got this line and this line. Actually, this surface limit of this hidden edge or hidden cylinder, and this surface limit of this hidden cylinder here and here. The only thing missed here, guys, it is again the axis of this hole. Actually, this is the drawing. It should be like this. Regarding the last class work, guys, this class work, okay, it's a good practice for a slanted surface like this. Dimension given, this is flat surface, this is flat surface, this is slanted surface, not parallel to xy, not parallel to xz, not parallel to zy. Now from the front view, guys, you will see, you will get the same shape but different size of this surface. So we have this surface, flat surface, flat surface, flat surface, and this is the slanted surface. On the top view, same shape but different size for this flat surface, slanted surface. This is flat one, planar one. We go back to the front and show you the side view. All of this surface become one line. We have flat surface here and here and here and here. And let me now get the multiviews, show you the multiviews in a drawing file. Again, we are not here to teach you the Inventor, just to make the exercise simple and clear. So let me place this one. I will change the scale. Now I will project the top view. Take the right side view. Just to remind you, this is the isometric. Again, as you see here in this isometric, guys, this line, it's a surface limit. We should not be in the isometric view, and this one. Now, top view, all of this surface is this surface. This surface is this surface. This surface, guys, it is this surface, and this hole, this gap, this gap. Front view, guys, this surface from here to here, it is this surface. Now, this surface, it's a small surface, this one. This one, it is this one, and this one, actually, this one. And here we have two hidden lines represent this gap or this hole, the surface limit here and surface limit here. And we should also, by the way, here we have this visible edge, we have hidden edge, and we have center line or axis of the circle, all of them in this location. So the priority for the visible line, but we can try to add an axis here and check what will happen. It will be extended outside a little bit with a gap. It should be with a gap. And here we have to place, on the top view, place center lines. It's very important to write or draw center line here and center line here, guys. And we can draw a center line like this here also. Now, in the top view, this surface is this surface, this surface, this surface, and this surface, this surface, and this gap is visible. On the side view, guys, all of this surface is just one line. What this hidden edge, this corner or this edge? What about this hidden line? Actually, surface limit of this circle. This line, surface limit of this circle. We have two here. We have two circles. It's very difficult for me to add a center line here and a center line here. So guys, here we have to draw a center line here, guys, like this to present this one, and this one like this to show the center of this cylinder, and this cylinder we have two halves. So this is the multi-views. Last thing I want to show you, maybe it's better to So let us show you this one as like this. So I hope that I did my best to make the second class of orthographic projection or multi-views clear, and we have to practice more and more and more to get more experience on how we can draw the multi-views. Thank you so much, guys.